right. Good morning, good afternoon, good evening. My name is Rich Bowers, and we're here for our next installment of Our Technology. Today, we're going to be covering cloud now and the evolution of where it will be in the future. And I'm here with two really special guests. First off, we have Cognition Jumps instructor covering our data section, Christina Torres, who is AWS certified, correct, Christina?
That is correct.
Awesome. And then joining Christina and I today is going to be our training manager, Matthew Truelove, who has a plethora of AWS credentials, AWS practitioner, AWS solutions architect, as well as the authorized instructor certification. Is that correct, Matt?
That's correct. Hey, Rich.
Hello. So I think we're in good hands to talk about cloud today with both of you. So let's kick it off. Let's start off in a great spot and just say, how did the cloud become a thing? Like what was the need that came of it, and how is it so massive and everywhere right now? Matt, you want to kick us off with that?
Totally. History lesson here. It's kind of fun to talk about. I'm going to put the lens here through one of our specific cloud providers out there with Amazon Web Services or AWS. 1996, hop back in time. We have Amazon Retail, right? Online bookstore. And they quickly grow in the dot-com era and expand their markets through North America, their bookstore, and then eventually full retail, right? Online retail, to then markets overseas as well, outside of the US and North America. And in that process, the cloud, to quote one of my coworkers here, is an internet connection to someone else's stuff, right? There's got to be physical servers somewhere, whether it's data storage, compute, or databases, right? Whatever you're doing on the cloud, there's going to be these servers powering these systems in various locations. And so Amazon Retail between 1996 and 2006 is growing, and they're building data centers around the world to reach their different markets. Why is this important to actually build around the world? We have something called latency, right? And it's basically if I can reduce the distance in the server that is powering the website that you're going to, Rich, if speed is constant, then I reduce the time, right? So the closer I get the physical server to you, the ideally the faster the response time is in your experience for that website or whatever it is you're trying to do. So this is what Amazon Retail is doing. The cloud doesn't exist yet, right? We're in the time between 1996 and 2006.
All right.
And 2005, right? We'll say 2006 is when AWS officially launched. Amazon looks and there's like, hey, you know what? We've had some growth, some trial and error. We've built data centers around the world, and we've come up with best practices, protocols, standard procedures for how to manage and run them in a uniform fashion for a fairly large company at this point. We have a product. We have excess capacity in our data centers, right? We've got compute, storage, our own database systems that we could potentially rent to other customers through the internet, right? So we're going to let you rent our capacity at our data centers around the world using your internet connection. So if I'm a new company trying to sell t-shirts or whatever it may be, it doesn't have to be retail, and I don't want to build these data centers or rent data centers around the world, I just want to use something that someone else has built already. That's the cloud, right? That's where AWS came about in 2006.
So that's incredibly important, right? So AWS, what you're telling me is they're the early mover. They're the first to market. Were they the ones that just started with this concept, or was this something that was a dream elsewhere, and AWS just said, hey, you know what, we're gonna make the move on this?
I think it was a process that had been shared obviously by dreamers, right? It was an idea floating around. I think AWS was first to market on aspects of it, but really kind of coined the cloud as we think of it today. You had the capacity prior to 2006 to actually rent an entire data center from like IBM, for example, and manage and run that. but you were responsible for that data center, the physical building, the servers inside of it, that sort of stuff. You either had to contract people to work on all that sort of stuff. When you use the cloud with whatever provider, in this case, we're using AWS as an example, you offload all of that data center responsibility so you can focus on your apps, your websites, all the cool things the cloud can do to be hosted by the cloud without having to manage that infrastructure yourself.
Oh, cool. And I want to hear more about the advantages as well, of course. But Christina, so break it down for us a little bit. If you hear the word cloud, and now I know the cliche saying is, hey, it's just mystery, it's things float in the air, but it's really, really simple, right? What is the cloud? And maybe stemming off of how Matt just explained AWS.
So the cloud, in simple terms, is just going to be taking several computing services like servers, storage services, and software, and putting it on the internet. And then once it's on the internet, you're able to access it from any machine as long as you have like just the right login credentials and specified access to those resources.
Okay, excellent. So then I can interact with it anywhere in the world, right? And I'm basically utilizing another company's servers that's storing my data. Is that kind of it in a nutshell?
Yeah, in a nutshell, it does get a little bit more complex where there's some more caveats where you can have the servers, they don't necessarily need to be on a external premise like managed by someone else. You could have it on your own site and the server is provided by one of these cloud providers like AWS, GCP, and stuff like that. But each one comes with its own benefits, advantages, disadvantages. But in a nutshell, someone else manages that server and those resources for you, and you have access to them much more easily and faster.
Okay, got it. So again, we keep hearing a lot of advantages here too, right? So no wonder why it's so popular. Um, when you're talking about, you mentioned on premises, I believe. Do you want to take that another step further? Can you tell me a little bit different about what's the cloud versus on premises? I know you kind of mentioned a hybrid model. We'll get into that later, but from just a traditional back in 96, 2006, that time frame, on premises versus cloud, what's the difference?
Okay, so typically in an on premise environment, all of your services, all of your servers and resources are created and managed by the company that's using it. And when you switch over to the cloud, you kind of transition all of that data that's stored on your servers and you transition it to the internet where Amazon or Google, one of those providers, they are going to be handling all of the underlying infrastructure that goes into powering them and allowing you to add on extra power, if you
Cool.
will.
Yeah, so there's updates, upgrades that are automatically happening right along the way, and that's some of the
Mhm.
advantages, right? Where we're on premises, you're doing all that on your own, right? Overall, and you have to be on top of it. Okay,
Yes, exactly.
awesome. Okay, cool. No, that's a great breakdown. Thank you for that, Christina. And now, Matt, going back to yourself, we got a lot of advantages. What are maybe three primary ones that you think of, or that when you say let's go to the cloud, if someone's moving to the cloud, what are some advantages?
Okay. So boil it down to three main points, Rich. Okay. Um, well, I'm here right now in Texas, right? I'm here in Texas. I can have an application, whatever application we're talking about, whether it's for machine learning, AI, API development, website hosting, front end. Um, I've got my code built. Okay. That's an independent process. But now it's time for me to deploy that to reach my target audiences, right? People trying to access my website, whatever it may be.
Mhm.
Well, here in Texas, let's say I'm a developer, but I'm contracted for a company that's working with European markets. Okay. Well, I can connect through the internet to a cloud region in Frankfurt, Germany, for example, and deploy my application there right now. Right. Little downtime. It's called go global in minutes. Right. And your major cloud providers, they've built this infrastructure that we talked about with AWS, for an example, between 1996 and 2006. And remember, location matters in terms of giving you the fastest delivery of content. Like if you're a gamer, for example, and you're connecting to servers on the other side of the world, right? For online gaming, you're going to have a slow experience. Same thing happens with cloud. So here in Texas, I can deploy my app in various locations around the world here today. Go global in minutes. Another major factor is the idea of paying only for what I use, or to stop guessing capacity too. So as Christina mentioned, if I do on-premises or private cloud, I'm responsible for those servers, right? And if I'm going to run my own data center, right, there's a lot of educated guesses and really intelligent people that help make these decisions, but it's guessing nonetheless. How much capacity do I need? How much server capacity do I need to allow for growth, right? To meet demand, right? But to not pay for stuff that I'm not using and is collecting dust. I don't have to do that in the cloud. I can stop guessing capacity and pay only for what I use.
And by the way, a lot of companies that they don't have the capabilities of AWS or Amazon to make all of these servers, right, and then sell them, right? So they're not going to be able to recover that cost of lost utilization. All right, so we got two. So you got a third one for me?
Yes, I do. You benefit from, I would pick a third one.
Yeah.
Economies of scale. Economies of scale. So with several of the major providers, you have such a large user base now in the cloud. There's increasing investment year after year for cloud and different deployment models, that it's driving down cost, right? The cloud is getting cheaper to me as an individual freelancer or instructor or contractor, whatever it may be, because of that aggregated usage around the world.
That's going to help for business. All of those, right? Yep. You're going to have you said go global minutes. Everybody wants something fast, right? Fast and instant as much as possible. Pay as use. Why waste my money elsewhere? And then you're talking about costs, right? Just getting cheaper and cheaper as it goes. I got to ask, do either of you any disadvantages of going to cloud?
So when it comes to cloud computing, if you have it completely on the cloud, then the servers that are held in data centers, those are not going to be like solo owned by the company. So data isn't going to be just the company's data on one server. You may have one server holding 3 different company datas, which, that's great if you want to be cost saving, because it costs less money to share that server. But with that server being shared access, it does kind of degrade the level of security that is offered. So slightly less security on a fully cloud environment.
And that's a big one, right? When going through this, we hear about that all the time, security and just, be wary of cyber attacks or whatever it may be. Let's talk about ownership of the servers, I believe, a little bit. So let me kind of ask you then. So have you heard about private public clouds? Right. I think, Matt, do you want to take a little bit about that? Like, does that help for maybe some of these concerns that we're talking about?
Yeah. So private and public clouds, private cloud is synonymous with on premises, and that's going to be you're managing at like a nameless company that I used to work for. The entire 4th floor was their server room, right?
Got it.
And that powered their systems for like HR, different types of research they were doing that could be accessed on the internet, right? So it was their own cloud, but it was for internal usage, or it was for systems that they were maintaining themselves. So you have that granular level of control.
So let me ask a question. When you're also saying access on the internet, you're saying only for their company, though, right? Realistically, like
it could be
shared.
Yeah, I mean, they could host their own websites and stuff through that, right? But they're powering everything themselves. So they've got to from the physical space, the machinery, the software, they have that level of control. And so sometimes when we think of security, right, we think of what control do I have, and it can be a little daunting when you use the cloud. What do? You give up control to the provider, as Christina said. So does that make it unsecure? That's actually a debate right there.
And one that the AWS's, Azures, and GCPs are in favor of. Maybe it is secure, super secure, actually. So okay, so you have the private cloud now. There's this, I guess, is it kind of like a hybrid, basically like a private public cloud, right? Christina, can you give me a little bit more of a full definition? I think we got the private one down, right? And then there's this again. It seems like a combination. What is that?
So private public clouds is going to be that combination and kind of halfway point that fits the business's specific needs between private and public clouds. So this is going to be a mix of having, say, you'll have like a AWS outpost, which is when AWS provides either a server or I believe a rack of servers, and they will install it on your premise. And that is used to accomplish that kind of private cloud aspect. But on top of that, you're also going to be using resources that are still available and hosted on the cloud. So, like different AWS Kubernetes, for example, you may want to outsource some of your work to a cloud structures. That way, you could have information and details that isn't going to harm the security of your company available and outsourced to the cloud while still having your private data secured in that private server environment.
So it sounds like it could be like a win-win, right? So you're getting the advantage of potentially keeping your really sensitive data in-house and owning it while getting the benefits of the cloud. And then when I was going through this, I saw that a lot of use of the cloud right now is kind of easy workloads. And for those of you that don't see the visual, I do air quotes, easy workloads. So maybe the cloud holding email data, certain files, but nothing too sensitive. Matt, do you want to add your thoughts on that?
Yeah. So just building off Christina there, we've got the private cloud. Public cloud would be a provider, right? Such as AWS, Azure, GCP, and you link them together and you get hybrid cloud. You get hybrid cloud, and that's a very common architecture that any of the providers work with, right? And that's probably the most common there is. There's aspects of your architecture is like your databases, your backend, your front end put together on the cloud or privately in private cloud. And an example would be just as you were talking about email servers, Rich. Or what if I want to have? I've got an application and I'm getting information about my customers, right, on my website. So I've got databases hosted on premises, private cloud. Those databases get serviced by an application program interface, an API, something written in Java, Python, whatever it may be, that reads those databases and makes my backend. Well, that API could be hosted on public cloud, AWS, for example, but it can link to the databases in private. So I've got this link of two different sources coming together. And maybe I want to take advantage of the global distribution of the major cloud providers to broadcast my website that actually is the user interface, right? That you type in and go to Matthew.com and buy my t-shirts or whatever it may be, which isn't a real thing, by the way. And I'm leveraging the public cloud to get that worldwide coverage, but I'm feeding data on my backend from my own on-premises data center that I manage. And I put it all together, and that's hybrid cloud.
Okay, good to know it. And yes, on the side, I checked. It unfortunately isn't a website yet, but I think you might have a following if you end up doing it. So when you're talking about these hybrid clouds, I just want to hit on this more because everything I'm kind of looking into and hearing from you all, that's growing, right? I mean, that's what, because you had like that kind of initial move. I feel like we're like, hey, we'll like throw everything on the cloud. And then they start getting some of these concerns. Obviously there's tons of advantages. You don't want to lose those advantages, but I think almost that control factor for companies on the security pace makes them on the security side makes them feel it's more secure either end of the spectrum, right? So when I'm looking at this, I see hybrid scalers. Does that fall into the same exact thing? So if I see the term hybrid scalers, is that somebody who is using it and then using both public and private in this blend while being able to dynamically scale up as needed a little bit quicker? Am I in the right area with that? Yeah, you want to go for it, Christina?
I just wanted to mention that my understanding of hybrid scalers is like if you have this hybrid environment of private and public clouds combined to some degree, you're able to scale up your resourcing needs either on the private or public side, depending on your specific needs. So like, if you need to expand the amount of storage devices, RDSs, that are hosted on your private section of your model, then you are able to up that. And also, but that is isolated from the public side of things, where if you wanted to scale up that end, it is, how do I say this? If you wanted to scale up that end, it's isolated. But Matthew, I feel like you would probably be able to sum that up just a little more succinctly.
That was good though. Go ahead, Matt.
So yeah, absolutely. Thanks for that, Christina. The mechanism of hybrid scaling I can think of specifically is I've got to make a dedicated connection right here in Texas. That's where my private data center is. And let's say I'm connecting to a cloud region in Virginia. Well, I want a 24/7, never turning off connection, private connection between my database and the example we talked about before and the front end website hosted on the cloud in Virginia. So if I'm going to scale that, the idea of scaling is making sure that the infrastructure can continue to meet demand, right? As traffic increases, it's like adding lanes to your highway, right? So making sure that our traffic patterns can continue to meet demand or not. Scaling in is a thing too to save money, right? It's not always about just growing. Sometimes you want to contract, pay only for what you use, remember?
Yeah.
Well, there is these hubs, right, for most of our major providers. For AWS, it's Direct Connect. And so if I'm here in the a metropolitan area in Houston, my data center would get plugged in to a hub, right? And then that hub would send me on like the private subway to the region in Virginia. And that hub is designed to scale and help meet demand without adding any network constraints to my hybrid connection that I have.
Great. And so the hub helps out with, you mentioned before, location matters, right? For latency. These hubs help out with that as well, going directly to it.
Yep. So they've got these hub buildings all over the world, and I connect to the closest one for my private on-premises cloud, and then I'm in the system. I'm connected to the matrix, whatever it may be, and then I go on the private routes to the great beyond in the cloud.
Awesome. Well, thanks, Neo. I mean, Matt. Yeah. So let's keep talking about latency or location, I should say. I keep seeing this thing edge, right? You see edge and some benefits over potentially cloud or partnering with cloud, right? Especially when you get into IoT and all that stuff. But I believe, Matt, you can you give me an explanation of keeping it with the location and talking about the edge.
So this is one of my favorite things to talk about with students, because you sit here and you talk about cloud and everyone thinks of an internet connection to someone else's stuff, right? As Christina put it earlier. And that's mostly true. But guess what? Again, I'm going to fall back to the tangibles that I can talk about with Amazon Web Services. There's actual physical devices, like things you can rent and buy. And Christina mentioned one with something called Outpost, where AWS installs servers to help facilitate private public clouds. Well, another thing that we have with edge computing is there's this physical little box, right? That's got tiny virtual machines and data processes and basically AWS software running on it. And they can ship it out to you. It's called a snow cone, AWS snow cone. And you can actually attach it to a drone. Like it fits in your mailbox, you can attach it to a drone. And there's a cool little video that came out a little while ago showing this. They'll fly the drone around, and they were looking at analyzing roofs to put solar panels on them. And the drone is collecting this geometric data and patterns, and it's putting it on this box, the AWS snow cone that's attached to it. And then when we're done with that, we then take that box, the snow cone, off the drone, and we ship it back to AWS, and they load it up on their system.
And by the way, when that video came out, I think, Matt, you sent me like 3 times. I was like, I got it the first time. And you just kept sending it and sending it. It's super exciting. You can see how passionate Matt is about that. Christina, you want to chime in there?
Yeah, no, that just reminded me. Didn't AWS also come out with in a similar field, the snowmobile, which they use to transfer large amounts of data from one location to any distance? Since like if you have to like download a super large file, say it's in like hundreds of thousands of gigabytes of size, you can't just stick it in an email and send it off. You have to like the most straightforward way would be in the same realm of like loading it onto a flash drive and then like hand delivering it to Matthew in Texas. But AWS made a solution to that, which is like I think it's called the snowmobile truck, which is like an actual truck on wheels with, I guess, full of servers that you load your data onto, and then you can transfer where the data is actually being held. So that's pretty cool and funny naming.
It is so cool because people think about with an internet connection, I'm just gonna, send my data through that. But just as you talked about, Christina, I was gonna ask you, like, tell me what this thing looks like. It's a literal container, like shipping container on a semi truck, right? That gets shipped around the world. So if I want to, just as Christina said, send large amounts of data from point A to the cloud, right? A 10 gigabit per second connection. This was Andy Jassy several years ago talking about this. It take 26 years to send exabytes of data. Exabytes of data is bigger than petabytes of data. Let's just put it that way. It's a lot of data. And so 26 years. This was a few years back, but I don't think it's gotten below 2 decades for that amount of data. An exabyte of data would be like an entire data center's worth of data. So what's faster? Call up AWS, have them ship this truck out to you, connect a faster local fiber optic cable and fill it up like a fire hose, and then physically ship that back to the data center. It takes maybe 6 months, right? But it's not 26 years.
Wow, it's so creative overall. And I mean, I don't know if you guys know this, but why do they keep referencing snow? Any reason? Is that I may have missed why? No?
You know, unless Christina, you have any thoughts? I'm only kind of guessing here. I'd actually have to look that up. Why is it snow? Yeah.
My guess is they came out with snow cone first, just from the shape. And, as they released products that were in the same field, they said, let's keep the naming convention train going. Think of things that are related, snowmobile, snow cone. Isn't there something in between that as well?
Yeah, so there's Snowball Edge. Snow Cone's actually the newest one. Just a quick note there. But yeah, there's the Snowball, the Snowmobile, and the Snow Cone.
They're just keeping it on brand. That's all it sounds like, right? So I mean, and that's and so we talk about edge computing. That's kind of what I was running into here is you get these devices, they're near a physical location, they're able to collect data right away, as well as also in terms of exabytes of data. If it's too much to transfer through the internet, there's this physical trade-off. So am I on the right I'm on the right track right there, right, Matt?
Oh, I just wanted to add my one liner right there
Yeah.
is the when we talk about edge computing, kind of going back to the example with the snow cone on the drone,
Mhm.
it's an extension of the data center, in this case, the cloud data center in the field, right? So I'm doing field work, whether outdoors, in hot environments, wet environments, right? Collecting data, using computing services, putting it on this device, and then getting it back to a data center, edge computing.
One of the and Matt, thanks for summing that up. That was awesome because it actually teed into one of the coolest things I saw. So I believe it's Red Hat. Red Hat has one of these edge computing, I guess, devices, servers. Would it be called servers to some extent? Actually on the International Space Station, because taking all the data from up there, sending it back would take forever, whatever it may be. So I thought that was pretty neat. So it hits on exactly what you're just saying. It is physical, but it's outside of a data center, right? That you can transfer manually as you see, or in some cases with certain Internet of Things, it can send and receive data back and forth that doesn't need to be collected. Like say your light, if you have hue lights at your house, right? You just need on, off, that's it, right? Sometimes it could be something like that. So overall, time sensitivity. as well as data volume if it's too much to send through the cloud. So it seems like there's a lot of partnerships between the two. It doesn't have to be an either or, edge computing versus cloud computing, right? It seems like it's more of a partnership. Awesome, awesome. So
100%. Yeah.
perfect, cool. All right, so let's go into the future of maybe even now to some extent, right? And looking at the cloud, I think we all, especially after the examples and descriptions that both Christina and Matt just shared with us, I think we have a really good grasp on it, right? We have an idea. The curtains fall down. We know what the cloud is. We got it. So how is it playing a part with popular technologies now and in the future? So if I think of one of the most popular things, every single article on Wire that I see, any LinkedIn post impacting the markets right now is AI, right? AI and the combination of machine learning. So Christina, from just your background, obviously data is your field. If I think of the future or even now, AI and machine learning powered by clouds, what does that mean to you?
So that's going to be having those cloud services. So like, those, if you wanted to host like a distributed computing on the cloud, you would have that up and running, but using different resources on the cloud to host your machine learning models and applications. So Amazon in particularly, let's look at SageMaker. They make it easy for you to quickly deploy a pre-built machine learning model. And that's really important because building a machine learning model does take quite some time. And one of the ways SageMaker makes it quicker is just by easily integrating with some of the popular libraries that provide machine learning libraries like TensorFlow and PyTorch. But on top of offering those, it makes the building process of these models kind of streamlined and fast. And by doing that, you can kind of deploy these way quicker and implement them into your workflows. So that's super exciting to like get to start experimenting with. But like there's also other technologies out there where it's already kind of like a fully built out service, like Amazon Comprehend, where it's a natural language processing model and you're able to just immediately start using it, configure it specifically to what needs you want to accomplish, and start pulling data from it. So like if you wanted to like upload a document, say all of your, let's say I'm a manager of my magnificent company and I have all of my employee information in spreadsheets, I'm able to submit that to like Amazon Comprehend and look for different trends amongst that data and just really quickly pull out that information. Where if I was to build that whole thing myself, that could take me 6 months more, but more realistically, a year, because my machine learning making skills is a little bit slower as opposed to what TensorFlow would offer. Like if I was to build a machine learning model without using TensorFlow.
Only a little bit slower. Don't sell yourself short.
Just a little
bit. Yeah, but even with that Amazon Comprehend, maybe even something you use in the classroom. Overall, but overall, AI machine learning, the combination is efficiencies, right? It sounds like it's what I'm hearing. Is it's making, you said, the streamlined process. It's saving time with, you said, managing the distribution network. So where are things going? Quickly deciding faster than a human can, right? Even looking into it was cooling systems, right? Automatically kind of, moving around the temperatures as well, as we know that's such a sensitivity. Do you have thoughts on that as well, Christina?
I can't say I'm immediately familiar with machine learning models and cooling systems, but I can see how the connection would work because my first assumption on how it works is that you have a machine learning model and it's like reading, say, the outside temperature of the air and then like adjusting based on how people adjusted the thermostat beforehand, for example, to find out what the agreed on general good temperature is, and then monitoring that temperature continuously and adjusting the thermostat for that. Now, may have added some extra caveats there that the AI may not be able to do, but if that's what it is doing, it's pretty cool.
Right, right. And if they're not able to do it now, I'm sure. I mean, at this rate, next month, right? It might be in play. Matt, the other one that I kept seeing with this combination of AI is cybersecurity within the cloud, and that kind of comes back to our discussion at the beginning of this conversation, is the only disadvantage, at least the largest disadvantage, could be security. How do you think AI can play a factor with cybersecurity within the cloud?
Oh yeah. So this could be a whole podcast in of itself, but let's hit the major points right here. I When you talk about security in the cloud, um, we first have to make sure we understand that there's the idea of shared responsibility, right? So you got a shared responsibility model. If I'm going to put my stuff, right, my data, my application, whatever it may be, my stuff on someone else's infrastructure, I'm trusting them to secure that inherently. So the physical building, let's say in Virginia, right, for AWS, I'm going to make sure that, Rich, I'm sorry, you don't work for AWS. You're not walking into their data center and sticking thumb drives in those racks.
That's a good
Right?
thing. Yeah.
Yeah, exactly. That's physical security. And I've got to, in the shared responsibility of security, I got to trust the cloud provider to do that. But when I'm hosting applications on the cloud, great power comes great responsibility. I've got a lot of freedom. They don't know what it is I want to do, right? I've got a lot of cool things I can do and deploy. So there's elements of security that are inherently deployed, and then there's things that there's tools given to me that I have to build properly. There's a whole security certification, right? To make sure that what it is I'm doing in the cloud is being used the way I want it to be used. But going back to AI and security, then, if we're talking about those tools, right, that are available in the cloud, let's see. Do y'all know what DOS is? DOS or DDoS? You heard of that type of attack?
Yeah, Christina, it looks like
Oh,
you shook your head. You want to tell us a little bit about it? Just for those like myself who may not be as technically inclined.
Absolutely. So DOS, DOS, that stands for, I'm thinking of the distributed attack where, yeah, it is that, where you have someone attacking your system. I forget the acronym and what it stands for completely, but I know what DDoS is, the distributed version of DOS. And what it is when you have users basically flooding a system with requests and making resources unavailable for that application as a whole. And effectively, you shut it down or you prevent other people from utilizing it as well. And the distributed version of that, the DDoS, is when you have multiple users on multiple computers, or it could be one user who's just distributing the work amongst multiple computers and just flooding one service or system with requests so no one else can use it. And interestingly enough, to go on a little tangent, is this happened a couple of years ago as an example on Google. When Michael Jackson died, so many people Googled Michael Jackson death. What happened to Michael Jackson? Michael Jackson died. And Google actually temporarily shut down because they had misdiagnosed a DDoS, since so many people were just flooding the same request onto the system.
Wow. I remember where I was that day, actually. Yeah. All right. So that's a good breakdown of that. And Matt, so you want to pick up from there?
Yeah. So yeah, excellent. Yeah, distributed denial of service, right? It just as Christina said, it's attackers, bots, right? But I do an exercise in class where, let's say we got 20 people in class, and we have Rich right here, and we're all going to be unorderly and just ask a question at the same time, right? All 20 people ask Rich a question at the same time. There's no way you make sense of that. Well, I don't know. Maybe Rich can do it, but
You're too kind.
they're it's so you can't, as Christina said, request, right? It's jamming. You're jamming a targeted system. You're isolating thousands or millions of requests to a reduced target so that you can't make sense of it. And unfortunately, this has happened with critical infrastructure, with hospitals or power plants and other things. And so it's not about getting into your system, but then the companies, the businesses, whoever it may be that's being attacked, can't use their systems because it's being jammed, right? So it's in the cloud provider's interest to make sure that doesn't happen to you using their cloud services, right? Because ultimately, right, it's their infrastructure having consequences as well. So getting back to the AI part of it, there's a service called Shield with AWS specifically that is inherently applied to anyone who uses their services. For what? To help protect against DDoS, right? There's a level that's applied to everyone automatically to help protect against DDoS. And it is, you don't have to configure anything for the base level, right? It's automatically plugged in and intelligently looking for these patterns of requests from maybe sources around the world at isolated targets that fits the pattern of DDoS. Artificial intelligence is helping automatically protect you against that insecurity on the cloud.
Fitting name, Shield. Wow. With that. So, okay, cool. So that gives us a really nice breakdown of AI and machine learning. That's just going to keep growing. I mean, it's going to increase security, efficiencies, just make it even more powerful. And all this additional power is going to probably lead to the last two sections of our future outlook, right? First one that we want to talk about is cloud gaming and streaming, right? So have either of you ever utilized, I don't know, Microsoft xCloud or Google Stadia, I believe, and Amazon Luna, I believe they had. Any of you play it? Matt, I know you're a big fan of some games, I think, with your brothers. Ever dive in?
I have a kind of high level awareness of some of the options there, but I do know Google Stadia, right? Is it kind of like Stream or Steam a little bit as a library platform and community for gaming and networking?
Yeah, and it allows, all these allow streaming of the games as well. So
That's right.
this was something that, the cloud, that's how it makes it possible. It sounds like, right? The cloud makes this very, very possible. And it kind of ties in, just to give a little heads up as we talk about metaverse in a moment. But I guess overall, with this experience within cloud gaming, it has been hit or miss so far. I believe one of the three I mentioned is either not doing well at all or has shuttered its doors. But what are your thoughts about cloud gaming? I mean, are there advantages over that versus a PS5, sitting in my house? What do you think?
So, my understanding of cloud gaming, first of all, want to make sure that that is correct. It is the fact that you would be able to play video games without actually downloading it on your system. So the actual contents of the game are staying on the cloud and you're not actually using up any of the memory on your system.
I love the clarification. Yep. So kind of like a Netflix of gaming.
Okay. And I'm honestly surprised I don't see it more often now, especially since with games, you can never have enough space. One of the biggest complaints I always hear with gamers is I have to get another PS5 or I have to get external storage to fit all of my games because I don't want to I don't want to remove all of the progress I have because I've 100%ed Destiny 7 times. I can't lose that data.
Yeah.
So I
Yeah.
understand a push for it.
You would think, and kind of everything that I've always looked into is with this ability, you can get like much more powerful gaming. Um, as crazy as it seems, the the flight simulator games are so massive that you can't actually. Have you played any of them? I know that they're not incredibly popular, but they're really impressive. You looked into it?
I played a VR version of like a flight simulator type thing, and it was super cool. And you got to see everything and learn all the controls. But one of my problems I was experiencing is just it was super laggy. And I think
Yeah.
it's just because my system. And I'm wondering with cloud computing or with cloud gaming, if you will, um, are the resources also will I have less laggy games with cloud computing, cloud gaming?
So that's the idea. Yeah. So for what I was looking into was with the flight simulators, right? They actually do real-time weather. When you get really into it, real-time weather, you pass over real towns and cities and things like that, and obviously everything you mentioned. On a hardware device, there's just not enough, I guess, computing. There's not enough storage to hold all of this in real time, resulting in what you shared. The concept of cloud computing is that potentially that won't be as much of an issue. However, in reality, sure, there's going to be better graphics, but it depends on your internet connection, right? Usually the cloud services are going to have, more powerful services with specialized hardware and specialized software to give you the best experience possible. But if you don't have that strong internet, then it's just as laggy or potentially even worse. Yeah, Matt?
Oh, I was going to say again, it's trade-offs, but y'all got me thinking of the concept's been played around with for probably the better part of a decade. There was, I think, of Games for Windows Live a little while back. Was a little bit similar, and while it wasn't necessarily focused on streaming the game for performance enhancement, right, from using these powerful graphics capabilities from cloud providers to then render the game, as Rich said, you need a good internet connection to make that happen, or keyword internet connection. And there's some challenges that have happened in the past. But let's say I want to play a single player game, but it's powered by cloud gaming. What happens when I lose my internet connection, right? So I'm not even online gaming, right? I want to save the local file. I played Batman Arkham Asylum that way several years ago, and I couldn't save the game unless I was connected to the internet. So I think we've come a little way since then, though.
I think so, and it needs to. If we want to get to the next topic and our last one here, is metaverse, right? So metaverse, obviously, Meta's been kind of slow in their investments there, and AI has taken the controls in terms of all of our attention, I guess you could say. But let's say metaverse does become a thing, right? Or I think we're all in agreement the cloud has to be there for metaverse to be successful, right? Um, and so I guess let me pass it to you. Why would the cloud have to be there for a metaverse scenario, be it either a virtual reality environment, others, right? Depending on how you define the metaverse. But why is the cloud, you think, so important to that? Do you want to go with that first, Christina?
Yeah. So first, in order for the metaverse to happen, in order for people to connect with each other, it's going to be easier to host it on the cloud where everyone is meeting up on like kind of this shared environment. So having that available is, I want to say, a basic requirement for the metaverse to function.
So the cloud is basically this unlimited storage to some extent, right? In reality, where you can have massive multiplayer experiences, right? Anybody can basically an unlimited user count, right? As opposed to something more local. So the cloud allows this because that's what the metaverse is supposed to be, really, right? An unlimited interactive environment is kind of how it looks at. And so that's really what I think you're spot on. You want to add to it?
Yeah, actually, you helped me remember my point that I wanted to make is the other benefit that having it hosted on a cloud provides is the additional security. Because I remember for a period, I think Meta might still be pushing for the use of the metaverse in like kind of this professional realm.
Mhm.
So, like, if you're using the metaverse in this professional environment, you need to make sure that security is being a priority. And that's one of the things that I want to say all of these cloud providers do have in their pillars is just that guarantee of we will do our best to make sure that data that is hosted in this cloud environment is secure and has very slim chances of being stolen.
Yeah, and obviously with the AI combination, we're getting closer and closer to that security piece. It sounds like Matt, going to your point. Thank you, Christina. Going to your point about being able to save, right? With the cloud and metaverse and gaming, and again, the metaverse is not necessarily just gaming, and it shouldn't be in the ideal sense, but the cloud should allow persistence, right? Allowing for your data, your, I guess, achievements to be preserved, your experiences to be preserved, so you can shut off and go back to it later on, right? Unless we don't want you stuck in metaverse forever. So the cloud, you think, can get there where it allows that saving, so that way when after you beat the Joker in Arkham Asylum, you can continue and go on to the Penguin next?
Oh yeah, that's interesting. Well, for one, I never made it that far because I couldn't, I only played a few hours at a time, couldn't save the game.
Maybe not.
But Yeah, I mean, this is 10 plus years ago. We've evolved since then. So with the metaverse, yeah, it's very exciting. I When it comes to, I think we're kind of talking about cloud storage as it supports the metaverse here. And with cloud providers, like there's a whole new innovation. Not to get on too much of a tangent here, I'll bring it back, I promise. But it's serverless, serverless, and what that means is servers aren't going away, right? There's still got to be physical servers in the world making this electronic business happen, right? But I am further offloading that responsibility from me. So even on something like AWS, I can make my own virtual servers, as Christina talked about, virtual machines, and then use that for storage. But if I go serverless, I'm like, hey, AWS, I have this data, I have this application. I want you to make it happen, right? I want even less work to do on my part in AWS inversion of control, right? I want them to have more control and do this for me. So with storage, right, and serverless, there's database systems and there's things like S3, for example, that automatically replicate your data and make it secure and with no theoretical upper bound. So if I'm going to go into the metaverse, I can just dump data in these cloud storage systems. Like you said, Rich, there's infinite storage, and it'll be scaled for me automatically in the cloud. It'll be possibly version controlled if I want it to. I can add encryption security and other things to it. But it'll be readily available to power the metaverse with little infrastructure or control needed by myself as an engineer on the cloud.
Awesome. Yeah. Scalability was just something that I, at the moment, at least, couldn't see how the metaverse could achieve without the cloud. Right. So totally neat. Thank you for all that. Christina, anything to add on metaverse? You think Matt summed it up nicely?
I feel like Matt summed it up pretty nicely, honestly.
Awesome. Cool. So then as we talked about a little bit of the future and almost how the future is here to some extent, right? With a lot of this stuff, I'm interested to see how it progresses. I have just one more topic for y'all before I know you got class, projects, everything to do, right? So how we always want to wrap these up is just talking about basically positions, right? Opportunities, employments, roles, etc. Um, what are your thoughts on it? Is cloud overall, the knowledge of cloud for anybody in IT, is it required at this stage? What are your thoughts on that? Christina, you want to kick us off? I could see you thinking about it right away.
I am thinking about it because instinctually I want to say that not the knowledge of AWS isn't necessarily required, but like I think about how many benefits come from just like knowing what's available, even if your company isn't going to be using it or you're going to be using it, it kind of helps you get a starting point of like what is available for you to use and improve the processes that is going on in your work environment. And when I consider those reasons, I want to lean more towards yes, you should have some type of AWS knowledge, especially if you're in the IT field, so that way like you'll know what you are capable of doing, even if you don't necessarily have to do it.
Awesome. Awesome, Matt.
Yeah, so I'm a little bit biased, right? Specializing in cloud for our classes, but I'm going to push it for everyone. It's a common thread. There's things that we teach in almost all of our classes. Data class, teach cloud, right? Java classes and application development, teach cloud. Site reliability engineers, SRE, teach cloud. Uh, there's in 2006 on our history lesson, specifically AWS, they started with 3 services, things you can do in the cloud or services, right? 3 services. Guess how many we have today? Over 200, right? Over 200 different services. So when someone says, hey, do you know cloud? For one, you got to always qualify that too. Like, yes, in these particular domains, right? I've not done the gaming aspects, right? But I can talk to you about, application development. So yes, there is tons of opportunity. We talked to some of our jump pros in a different series, And I've talked to a couple of them where for one, the cloud's not been around 20 years yet, right? Senior engineering in the cloud at a given company might have 5 or 6 years of experience. So you can very quickly get your foot in the door and become senior in that technical domain. And there are companies that are looking to go further and further total cloud and migrate from on premises, right? We work with a few companies that are actually doing that right now. And especially since the pandemic, too, with unstable job markets and workforce changes and trends, a lot of companies have been leveraging new technologies on the cloud to automate processes, cut down costs, and even potentially reduce the amount of workforce required to do operations and such. And guess what? We have some pretty junior level folks who have been working in those roles specifically because they were identified as cloud talent.
I think that's a strong yes. Then yes, you're going to need it. You're going to need it, and there's no harm in grabbing one of the certifications. Putting that time in. You're going to use it one way or another. So, Christina and Matt, this was a phenomenal conversation. And I was fortunate to have it with both of you. I mean, you know it like the back of your hand, and so much information. I hope this helps not only myself, obviously, here, but everybody listening. So as always, thank you for your time. I'll let you get back to the cloud in itself. And for our technology, I'm Rich Bowers. Thanks for joining us, everybody. Take care.